Hello everyone, welcome to this video where we're going to look at how we can define elevation views on our model using the pre-existing grids. Now for a bit of background on this model, this is part of a creation series where we've generated this model using different grid definition tools and the floor definitions tool to allow us to define a floor plan and essentially create vertical stacks of that floor plan at different elevations. Now this whole concept revolves around the usage of grids, and as you can see I have a base grid, parent base grid, which contains 3 different grid sets within it. So I have my podium base grid, I have my tower base grid, and if I just rotate my view here as well, I can see that I have my core base grid as well. And to utilize this, I just click on the elevation tool at the top of the geometry window, and I can choose from different grids that are available in my model. So I can go with the parent base grid or one of the children base grids or one of the existing construction grids as well. And for this example here, I'll just stick with the base grids where we can select a frame from this base grid. Now this elevation view that we're going to choose in just a second will look at all the parts of the structure by ordinates to determine what to display. And it also allows us to connect objects defined with different grids. So if we want to select, rather than the parent base grid, maybe the tower base grid, for example, we could select that and still see all the data along that same ordinates within the podium grid or even the core grid, so long as they have share the same ordinates as that grid line. So for this example here, I'm going to choose line number 5 as my first one. I'll just scroll down until I find it. Elevation 5, and just to make sure I can see everything here, I'm just going to go to window tile, and it'll make sure all the windows are zoomed to extents and nicely sized. And we can see here, now on the left hand side, we've got an elevation view of frame number 5 along this grid line here. And this is showing us the elevations of all of the geometry in this elevation view and the floors associated with each. Remember that I've also given some unique names to some of the floors, like roof, the master floors for 6 and 2, and then base. And we can also see the podium that's extending beyond that. Now this is just one example of seeing, I guess, 2 sets of data, but let me choose a different grid. I'll choose grid number 8, grid line number 8 rather. So I'm going to go to elevation 8. And here once again, I can go to window tile, just to make sure everything is nice and clearly displayed. And for this example here, grid line 8 didn't have a podium grid line or a podium geometry line associated with that. The spacing is different on the podium than it is on the tower. So we have 5 meter spacing in the columns in our tower and 10 meter spacing on our podium. Hence why we don't see the inclusion of the podium on this particular elevation view. But it still allows us to see the rest of the information related to the core wall and the columns on either side. Now one of the handy features of this type of elevation view is adding geometry to our model. So I'm just going to actually close some of these views here, and I'll expand the geometry view again. And what I want to do now is look at the podium grid, and specifically grid line N, which is at the end of my podium. So I'm just going to select grid line N, and actually, you know what? It's probably just easier for me to switch to my podium because I have a smaller set to search through. And I can see here elevation N. And just like before, we can go in and we can say, let's go to the window tile. And what I want to do is add some eccentric steel bracing to this end frame of my podium. So I'm going to use the member definition tool. And because I'm in the active plan view, or elevation view rather, I can specify the 2D patterns that are being used, and I actually have this set up already for inverted V-brace. And when I selected the inverted V-brace, I have the option to define an eccentricity ratio. An eccentricity ratio is basically utilizing the fact that we're going to define these braces based off the grid line spacing. And eccentricity ratio is just the ratio of that distance between grid line to grid line that an eccentricity exists between these 2 braces. So I'm going to also make sure that I have the correct section defined and the member type. I want this to be a truss member type. And all I need to do is just left click and drag around these elevation grids to add in those eccentric braces. And as you can see here, this eccentricity, this gap between the two braces, is what is defined using this 0.2 ratio. So that's 20% of the distance between these two grid lines. Now if I go back to the elevation view again, just like we did for the floor definitions tool, we can also define folders using this elevation tool as well. So if I select the base grids folder, for example, and with this folder selected, I can say, let's generate a folder or a set of folders based off of this. So here I'm going to generate a folder based off of the open folder that I've got selected, or the open grid. And if I just move this out of the way here, we can see all the different folders that it's created. And so now I can go through this and I can say, okay, well, I want to look at grid line F, for example. I select that grid line and maybe I'll turn off everything else and I can see the columns associated with that. I can also look at maybe a different one here. Look at grid line number 8 again, and we can see the data related to that. And the same thing for N, or in the past I looked at grid line 14, so I could see that as well, and I can see the geometry again associated with each one of these. And this helps when we're modifying our model, or maybe we want to load it. We can ensure that we're only affecting the data in this specific folder rather than everything else. So if we want to make fine-tune adjustments, this is a great way to go.